Okay, good morning. Get ready for the lesson. Please, later on you are asked to open the camera. Please be ready. Okay, while we are waiting, any students who have questions, doubts, anything unclear about yesterday lecture, let me know now. Okay, we will start the lesson very soon. Now, could you please open the camera? Let me know you're here. Okay, we will start the lesson very soon. My purpose is, besides letting you know you are here, you are attentive enough, but also a brand new day. Do not lie in the bed now. I know the weather being cooler, but you have to wake up. Do not lie in the bed. All right. Now, today's lecture, we will continue on the two small topic on page 30, drying agent and the use of concentrated. Okay, please take reference to it. The board is on drying agents. And if you have anything unclear about yesterday lecture, let me know now. Any questions so far you want to ask? Wang Zihin, are you here? 正透上 Anyone who see 陳潤忠? Anyone who's Simon Chan? Okay, all right, I will start the lesson right away. Any questions about yesterday lecture? Now, just like this one, I would like to ask you this. Just let you know if you know it. 陳應真, a forensics chemist collected solid, white solid of crimazine, and she suspected that the solid may be either ammonium sulfate, magnesium chloride, or potassium carbonate. Suggest how the forensic chemist could identify the white solid. Any idea in mind?陳應真.
Oh, I do. Potassium 可以用 flame test.
Potassium. We can use flame test. So, any expected observations?
It gives the left flame when.
Okay. It gives a flame. Yeah. What else? Now, all of you will also have a chance of asking such. Could you please keep track of it? Okay. Please try to search on the web to get the relevant information. All of you, please do it now. Flame test, potassium. What else? You just mentioned this. Flame test, little flame. If there is, it is the potassium ion containing. How about the others? Just imagine the case. While you do this experiment, what you just have is just white solid. You don't know what is it. So you mean that for the first time, you apply the solid to do flame test. If it gives a little flame, it is potassium. It contains potassium ion. Can you get my point? So in other words, that you may also have given a chance in which it doesn't give any characteristic flame color or other flame color. So what is the conclusion? Okay, can you get my point? So if you whatever test you are going to have, you think of test 1 first of all. You are going to do perform flame test. So we would have two conclusion. It's not little flame, no little flame. Now, no, what is mean by no little flame? It can be other flame color, or we have got no characteristic color. Can you get my point? So if you write down no little flame, it may be either one. So what is the message? I don't know. We will have got a other ion. Can you get my point? So you are going to do the step subsequently. Now, first of all, if you think that you have the little flame in the flame test, you show it's potassium ion, because you need to do identify, right? Identification. So carbonate ion, you still need to do the further test. So it gives another branch. Can you get my point? If it is potassium ion, what you have to do next? You have to do test 2. Can you get my point? So to double verify it is carbonate, what should we do next? You are going to add what?
Cl.
HCl, dilute, remember, dilute hydrochloric acid. So the observation will be
colorless bubbles are given off.
yes, colorless gas will be given off. And you are going to test with what agent? Lime water, which turns lime water from colorless to milky. So you will know that it is carbonate ion. Okay, is that clear? So the story will continue, right? By having this, if there is no other color flame, no little flame, you are going to do another test, okay, to double verify that it will be ammonium sulfate or magnesium chloride. Can you get my point? Because the answer is narrowed down as ammonium sulfate, magnesium chloride, and potassium carbonate. So the first test is for you to identify, is to narrow down the case to have potassium ion containing first. And then if it gives a positive result, double verify it is potassium carbonate by testing its presence of carbonate ion. Can you get my point? If it is not, if you think it's flame test, you want to guess it as potassium compound, but life is not so easy. You may turn to some other observation. So if it gives another observation, which means no characteristic flame color, you are going to think of it as ammonium sulfate or magnesium chloride. So you are going to do test 2. So what should we do as a test 2? Let's have a try. White solid. So you are going to do what? You are going to do what test? Wang Jingho, what do you think?
Silver nitrate test.
Silver nitrate test, how will you do this? You'll be given solid. How will you do silver nitrate test on a solid?
Dissolve it first.
Yeah, dissolve first, okay? So remember, you are going to dissolve the solid in distilled water and do the subsequent step. You are going to add acidified. You still remember that? Silver nitrate solution to the sample to be tested. So what will be the observation? 2, if you've got white precipitate, okay, the other one is no PPT. So if you think that you have got white PPT, I know that it is chloride ion. While you can verify it as chloride, but not for magnesium. So you are going to do further tests. You're going to do further tests to test for magnesium. Can you get my point? If you think it's no PPT, you may think it as ammonium sulfate, right? But you still need to double confirm the test for ammonium ion and test for, you do it both, okay? You test for sulfate ion respectively. Can you get my point? So this is how we get approached to the problem, because the term identify will give you a very high level of identification. You are going to make sure that the cation identity and the anion identity is shown in the question itself. Can you get my point? But not just distinguish. So remember of the term identify and distinguish is different. If you think it is, if you change the whole questions to distinguish only, so you can save so many steps. Some steps can be saved. Can you get my point? If you follow this logic, you first of all you do flame test. If you give it a lead flame, the answer for that compound must be potassium carbonate, and you need not do further tests on carbonate. Can you get my point? And then for other samples which doesn't give any lead flame, you are going to dissolve the sample into distilled water and add the acidified silver nitrate solution to the sample. What I mean is silver nitrate test, and wait for any appearance of white PPT. If there is white PPT, you already can give a conclusion that the solid must be magnesium chloride, but not ammonium sulfate. While for the other case, no observable change, you may know for sure that it's ammonium sulfate, not magnesium chloride. Can you get my point? While you need not do another test on testing for the presence of other ion. So this is the difference between the term identify and distinguish. Can you get my point? In other words, if you use distinguish, it seems like all one out. Just tell me distinctive features, okay? And you tell me the difference and it is okay. Now, for example, if you are asked, how would you distinguish? Okay, how will you distinguish Mr. Chin and Mr. Zhang? How will you distinguish between Mr. Chin and Mr. Zhang? Mr. Chin teaches chemistry, while the teacher that doesn't teach chemistry is Mr. Zhang. Can you get my point? But if you want to know what who is Mr. Chin and who is Mr. Zhang, well, you cannot tell the one who teach, right? You're going to identify which is which. You may ask me to show me your ID card, for example. Can you get my point? So this is it's quite different if you want to talk about the word distinguish and identify. Distinguish is of lower level as long as you can make difference the problem is solved. But identify, you really get to know what is the true identity of the solid. You understand? You understand? Okay. So of course you may think of more. It will bring to our concern, Mr. Chin. You haven't talked about text for sulfate, right? How will you test for sulfate? How will you test for ammonium ion? Now this one you know it already. How? Now for this I will leave it later. How about this? Ammonium ion. How will you test for the presence of ammonium ion? I add what? How will you test for the ammonium ion?
Put it in the dilute sodium hydroxide.
Yes, you add an alkali. It must be NaOH, but not ammonia solution. And then under heating or warming, again, what will be the observation? It will produce a gas, pungent gas. So, but you are going to test the pungent gas, but not do it by smelling. Now, of course, once you smell, it will give a very distinctive smell, like you go to male's toilet. Okay, that smell like urine. So indeed, it is ammonia, but you cannot just use this to tell it must be ammonia. You are going to do test paper, which turns moist what paper? Now, what paper? Moist what? Litmus paper. What is the color? Is it an acidic gas or alkaline gas? Do you know?
Hi. It is alkaline.
Yes. So how we test for the alkaline gas?
Use the red one.
Yes, litmus paper. While you look for the color change from red to blue. Okay, is that clear? So you use this to tell it is ammonium ion. Do you understand? So the whole case will be this.
Sir，睇唔清個字。
What pungent
個
gas?
圓圈嗰個
Warm. 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 Oh, maybe the drawing is too thick. I need to, yep. Okay, is it better? Yeah. Pungent. Warm. Okay, is that clear? So you can search on the web to get to know how to test for this. Okay, you will know it bit by bit as well. Now what my focus is show you the whole way of thinking, the logic. How you get approach to the logic. Is that clear? Do you have doubts? Mr. G, is it a must to do flame test as a first test? Is it a must? Ma Zihin, is it a must to do flame test as a first test?
Hello.
Yes, is it a must? Is it a must to do flame test as a first test? And I use other tests as a first test.
它你係 identify 定係 distinguish 咯
Okay. So can I do the test for alkyl and warming as a first test? Now, if I do this as a first test, the observation is a little bit different. For example, because you are talking about solid, okay, it's because you are talking about solid. If I dissolve in water, and add dilute sodium hydroxide to it, so two of them will give a positive result. Can you get my point? If I add NaOH, now, if I use test one as adding NaOH to the aqueous solution. Now remember, aqueous solution, first of all, is solid. First of all, I dissolve in water, I put dilute NaOH solution to the aqueous solution. So you would have three observations. One, white PPT. Two, pungent gas. So you're going to test three, no observable change. Can you get my point? So you are going to do the further steps. The pungent gas, of course, you know what is that? It is ammonium ion containing. How about YPPT? It is magnesium chloride, the magnesium ion containing. No oxo change is potassium ion containing. If you do this as a distinguish, right, you can just stop here. But of course, if you're going to do identification, what your test will only tell you the presence of ammonium ion. Okay, but you need to do the further test on other ions. Is that clear? Do you understand? For those who just understand what I've just said, could you please put a tick? If not, across. Now we come to this. Now I'll give you some time. So what is the hidden message? You of course will be challenged by thinking of the whole flow of experiments, and me, the Marcus, will be also be challenged because I need to check each own answer. Okay, I need to check each own answer and try to see if it's logical while the test is correct. If it's the whole flow makes sense, and I will give you marks. Can you get my point? So all various answers will be accepted. It depends on your fault. I will check your rate of fault, not only on your logic but also the accuracy. Any questions so far? I check your understanding. Just only 3 of you give a tick. How about the others? You don't understand? Understand, you give a tick. You don't understand, give a cross. On your name, you may have got 1 sign, right? Let me know. Or most of you understand, right? Which part will you not understand?
頭先你收尾嗰段，我掛住睇嗰個抄嗰個嘢，冇聽到少少。
我講緊係成個 flow 啊嘛，我就 check 你個邏輯同埋 check 你個答案究竟佢啱定錯啫嘛，我就係想講呢樣嘢啫。咁即係話咧，個個都有唔同答案嘅，明唔明？最緊要你睇清楚佢係 identify 定 distinguish。如果 identify 嘅話咧，就 cat line and n line 兩個都一定要話到俾我聽點測試到出嚟。咁 distinguish 咧，淨係要知道咩啊 ？odd one out，OK？、明唔明？咁第二啦，我頭先講咗啲咩啊？就係啲 test 究竟做邊個先啊？有邊個即係有冇一定話要做 flame test 先？係做簡單嗰個先，分到就得啦，係咪啊？咁所以咧，你做 flame test 又得，你做其他嘅 solution test 又得。邊個係排第一係冇問題嘅，自己要排第一之後，你知道你要幻想下嗰3隻 chemical 做咗第一之後，下一步做乜咁就得啦，明唔明？咁樣到先嘅啦。好 ，drying agents and I indeed some exit here is said to be drying agents, and you may see some questions, very strange questions. In the preparation of gas, we have got 3 parts. One of them is called a drying agent, right? So what is said as a drying agent? Some exit is said as a drying agent. For example, concentrated sulfur exit. Concentrated sulfur exit. 呢一個嘅濃嘅流酸。So we would itself being a dehydrating agent, a very nasty chemical because it is dehydrating, oxidizing, and also corrosive. Now, I would like to tell you what is that 3 terms. Dehydrating, remove water. Oxidizing, 氧化性. So it may oxidize some chemicals, even though it is not so, it's very stable. For example, copper. Okay, even copper can be oxidized. corrosive, it is to your skin, for example, it will cause some burn on it. So concentrated sulfuric acid is quite different from dilute sulfuric acid because it's not just irritant, it's corrosive. Now remember, irritant, the term irritant is for weak acid only. So it is a milder version to describe the word corrosive. It's milder version. Corrosive is more severe version. Can you get my point? To tell you the action on the skin. Now, this is because because it's dehydrating, it will be quite fun to see that if I unbottle a concentrated sulfuric acid, or just like this one, I put it into beaker, I leave it for some time, what will happen? So it will, the water level will rise. Can you see that? The water level will rise. So which means that they will absorb water vapor from air. So we will call that hygroscopic. Underline the term hygroscopic. Now you may heard of this term in your MC as well. Hygroscopic. While some chemicals, if I besides Consol, some of them they also accept as absorbing water. Now this time you talk about solid. You may heard of some you have buy some drying agents at home, right, before Chinese New Year. Now in your wardrobe, besides putting some activated charcoal, right? Some of you love to get some drying agent, just like cups of Daibanjiao. You know what's that? So it's used to absorb water vapor in order to prevent molding of your clothes. There are so many different chemicals found inside the drying agents. So anhydrous calcium chloride is just one of the case. If you go to the Japan, now you may find so many different brands of those drying agents. Some are cheap, some are expensive. For the cheap one, you may usually you may turn to see the ingredient, and it's usually anhydrous calcium chloride. So this one, this chemical is very simple. You may have this bottle. We've got so many white solid of anhydrous anhydrous calcium chloride. So once I leave it for some time, what will happen to the bottle? Those white powder will go away, but at the same time, some water it is found inside afterwards. So indeed, what is that? It is calcium chloride solution. What is happening is that the water vapor will come into the container, okay, and calcium chloride will absorb it, and finally the water absorb it, they will form solution. So we will call this substance a deliquescent substance. Deliquescent, okay. So it will absorb water vapor from air and finally forms a very concentrated solution. Now, besides anhydrous calcium chloride, we may have got so many other chemicals. I'll give you one more example. This is solid sodium hydroxide. In terms of caustic soda, Corrosive. Do you still remember the caustic soda this time? A bottle with a white bottle with a wet cap, with so many tiny drop platelet inside. You shake it, right? You may feel that it's the solid. But if you open the bottle or do not close the bottle so tightly, finally those solid will then be wet, and finally the whole solution will be formed. Can you get my point? So we will call this substances a deliquescent substance. We will use either hygroscopic or deliquescent substances as a drying agent. Okay, so of course you may find these are chemical in some way, like food, electronic products, and many manufacturing industry. Now, of course, you will not find any OH or consult in food because it's corrosive to you. Usually, what is the drying agent found inside packaged food? Anyone who know? Anyone who know? 有冇人知啊？ Sorry?
通常係一包嘢嚟喎，但係唔知咩嚟。
係咪 helium 嗰隻
What is that?
helium？
I can't hear it. Speak louder, please. Sorry. 係啊，佢食個包嘢叫 drying agent 嘛，跟住叫你 do not eat 啊嘛。Anyone who have tried cut it open?
係咪白白地透透明嘅一粒一粒嘅嘢？
係白白地透明一粒一粒嗰啲係咩嚟嘅？就係防潮珠嚟嘅，防潮珠 Silica Gel。So silica gel, it is in terms of silicon dioxide. Of course, it is because of the making process. I want to make it such a way that it can absorb water containing, but it's not purely silica dioxide. Okay, it's something else. Silica gel is also a drying agent, but it's one way. If you cut it, cut the package and you pour it out, it can be anhydrous calcium chloride, a white solid. If I cut it open and put it and you just take a look on inside, if it's black solid or brown solid, do you know what's that? 你知唔知啊？如果見到顯出嚟黑色嘅，其實嗰啲咩㗎？ Of course, it is a mixture, but mainly is iron powder, activated charcoal, etc. 嚇，鐵粉嚟㗎 ？Yes. So what is the principle of having iron powder as a drying agent? Yes, it will absorb water vapor. Besides, it will also absorb something in the air. What is that? You know what is it? 唔知。How would iron powder absorb water vapor? 明唔明最？ How would iron powder absorb water vapor? 有冇人知啊？冇，做咩電視聲？好驚啊！爆炸好驚啊！如果講唔到就喺chat box 度講啊。蔡瑞希啊 ，do you know？
我想即係我諗啦，rusting process 咯，係一個
Good. It's rusting process. So the iron powder react with oxygen and water vapor in air to form rust. So if you use that package for long, if you still cut it and you just open it and take a look inside, if it's brown, which means that the absorbing oxygen and also the water vapor has been completed. So why will we need to use iron powder? It gives you an advantage. First of all, if this package is put inside a package of oily food, for example, mooncake, you usually use this. Do you know why? Because the oil, if I place for a long time, it will turn bad. It will give you some bad smell. We call that rancid. 油會益㗎嘛. So the oil will become rancid. It undergoes a chemical process with oxygen and water. So if I have an iron powder as a drying agent, this is good because it will help absorb oxygen, both oxygen and water vapor, both will make the oil rancid. There are two elements. Okay. So usually we'll have this. Okay, it's clear. So anhydrous calcium chloride is also another choice. but at this time, anhydrous calcium chloride only will absorb water vapor, but not oxygen. Do you understand? Silica gel is also third case, but of course, no consult, no NaOH, right, as a drying agent to dry food. So besides, you may have calcium oxide as well, which will help absorb water vapor and also carbon dioxide. Okay, all of you please mark it down. They will absorb water vapor and carbon dioxide. This one H2O, this one H2O. Now, so because of the different states of the drying agents, you may use the different setup. Now you may see the one on the left hand side or right hand side. The left hand side it will deal with the liquid drying agent, while the other two you mainly deal with the solid drying agent. Can you get my point? So because of that, you need to have this structure. Now take a look on that structure very carefully. The class practice will ask you this setup again. As said before, some of you may have got some colorless or white or milky granules. Okay, it's silica gel from Jiu. But also you may have got another type of drying agent like this, the one which it is originally blue. While if it is moist, if it's moistened, it turns pink. Right? It is another type of silica gel. Do you know? While this type of silica gel, it is mixed with one chemical. Do you know what's that?
Like cobalt.
Yes, not cobalt. It's called cobalt 2 chloride, the chemical. That cobalt 2 chloride chemical would have such ability of changing its color in different stage of dry or wet. Okay, so there are two types of drying agent. If you talk about silica gel, one is just colorless beads. It only absorb water, but you do not know whether or not the silica gel is still functioning or not. Okay, because the drying agent, while you absorb the water in the food, will no longer absorb any water vapor. But you use that silica gel with color, it will give you a consumer a good sense of a good indication whether or not the drying agent still functions. Can you get my point? So what will happen if next time if you buy this drying agent, if you open that, you may see it as pink. What is the meaning? It will no longer act as a drying agent, right? So what should you do next? Throw them away? It's a waste of money. Yes, you can do the process backward. Anyone who knows? You can do the process backward. How? Now this one can be reused. Drying agent can be reused. Zagahi. How will you tackle?
整翻乾，曬翻乾佢。
曬翻乾佢。Possible. You can dry it under sunlight, but it can only help a bit. Now, usually people would put this into oven.焗爐啊。You'll put it into oven. This can be reused, okay? You put it in the oven and wait until it turns back to blue, and you can use it again. So remember, this drying agent is so nice, right? Because it is reusable. Funny? Now, this setup, we call it exsicator, 乾燥器. So it is a place where the chemicals, which is said to be deliquescent chemical, which is put inside. Okay, people who prepare info day should understand what is that, because very often you ask for some chemicals while you open the bottle to find the solid. The solid has been wet. Okay, so those solid may be said to be deliquescent. Okay, of course, do you know that sugar is also a deliquescent material? Sugar, table sugar. You know it? It is also a deliquescent material. Once I place the sugar on the container, untight container for long, it will clump together.
Clump together.
Clump, C-L-U-M-P, clump 結成一塊，結塊。
哦，OK，
clump 啊，你知唔知㗎？屋企嗰
啲糖會變硬咯。
係啊，咁點解啊？唔係啲糖自己硬咗啊，係啲糖吸咗啲濕啊，吸咗啲濕氣啊。咁點樣做㗎？屋企我會唔會放 Silica Gel 落去啊？啲糖
我攞筷子嚟篤咗係。
咩啊？
我會攞筷子嚟篤爛佢之後倒出嚟。
哦，剝爛佢，仲有咧？有冇人聽過？If you go to 茶餐廳，people would use one important food to help. You know it? Fried rice. But this time of fried is not deep fried. 炒嘅米啊，炒乾咗嘅米，知唔知啊？ So that's why you will also as a bottle of salt as well. 你會見到呢啲鹽啊，鹽罌咧入邊咪有米嘅。咁啲米嚟做咩咧 ？Is also help absorb water vapor。你知唔知㗎？得啊，梁君耀你真係獨留在家中啦，你個樣。
好慘啊！好慘啊！
係啊，你個樣好獨留家中啊，唔掂啊，唔係好知出邊發生咩事咁樣。Now take a look on this class practice 14.7. Okay, take a look on this. Some setup is wrong. Tell me what is wrong about this. Wow. Let me see. What's wrong with setup 1?
管嘅長度錯咗。
係。So what will happen if I do this setup? Is it? What's wrong with this? If I do such action like this, what will happen? If you do action, what will happen to this? The depth is
啲acid 會流出嚟啊。
Yes, because of the air pressure. The design of this, it is the incoming gas cannot pass through the con exit. Still worse is that the exit will then be drawn out. Okay, the exit will come out. The gas cannot be dry. Okay, because HCl is here. So you are going to bubble. You are going to bubble the gas instead. Bubble is a verb. You should bubble the gas into console. Okay, so what's wrong with that is the end of the delivery tube for incoming gas is just above the con exit. So the gas can't be dry. So what should we do? You bubble the gas into con exit. But that the problem is worse about this. The term of directing the dry gas, it is now immersed, IMMERSED, into console. So what will happen? The consequence is that the exit will flow out. Okay, the exit will then be pushed from inside to outside. Okay. So what should we do? Is to make sure the end of the delivery tube should be above the exit. Okay, is that clear? So this is point 1. How about setup 2? What's wrong with it? What's wrong with it?劉軒總。You dry HCl with calcium oxide. What's wrong with it?劉軒總。Now, calcium oxide is a drying agent, right? So can we dry all gas? Now it depends on one more point. These two, what will happen when these two meet? Why? Why not? Why? What is the chemical reaction? Calcium oxide is a base. HCl is an acidic substance. So what will happen if it meets the two? What is the chemical reaction?
出calcium chloride 同 H2O。
So what is the hidden message? If you want to choose a drying agent, you are not just take a look on the efficiency or effectiveness of absorbing water vapor, but also you need to be aware that this chemical will cause any other reactions with the incoming gas. Now, HCl is an acidic gas, so you never get mixed with a basic drying agent. Similarly, if you want to talk about this, now this one, so what should be replaced? I changed this one. This, I don't want that. And this one, I change it to what? Anhydrous calcium chloride is a case. It's more possible. Now, similar, you think it backward. How about ammonia? Ammonia cannot be used with one drying agent. Can you suggest? If I want to dry ammonia gas, you cannot use some drying agent. Could you please suggest one of them? 用同一個 logic 去諗啊，黃子軒。
係
Drying ammonia gas, some drying agent cannot be used to dry ammonia gas. Could you please give me one example? Now for the others who know it, you may also turn on mic and tell, or you type in the chat box.
Sulfuric acid 得唔得？
Consol 係唔得嘅，個答案係 consol 係唔得咯。你答唔得嘛？唔係問我得唔得啊？
係問
係咪啊？係咪？記住第二兩樣嘢啦。一 first of all, the sulfuric acid which act as a drying agent only Consol can do. Only Consol can do. Second, Consol cannot be be used to dry ammonia because they both have neutralization. Do you understand?
Okay.
Yeah. Okay. So we come to this. So be aware of those type of questions. And finally, here comes safety concern. As said before, corn acid, it is more corrosive. It's corrosive. All of you, please mark it down. We use the hazard warning label corrosive. But for dilute acid, we will use the word irritant. Now, both will cause harm to your skin. Now, corn, you talk about mineral acid. We have got corn HCl, Consol. Now, can you see that? It will give you quite high percentage by mass of the acid molecule in the acid. Now, the remaining is just water. And nitric acid. Okay, with the molar concentration 12m, 18m, 16m. So next time while you go to the lab, I usually put it into film hood, right? You will see this. Corn nitric acid, it will decompose the brown nitrogen gas to brown nitrogen gas and oxygen. So light can speed up the decomposition. So I put it in the brown bottle. Okay. Is photodegradable. If you use this acid, remember every time if you have got too much corn acid on your bench, you want to dump them, you want to throw them away. What you do is to first of all dilute it before you dispose. Now, usually you can just dispose through the sink directly, but first of all, you have to dilute it. So first of all, the acid should be poured into the water, but not in reverse. I will easily find a case where people who love to rinse the apparatus, like I open the water tap with the chemicals inside and then let the water flush into the chemical directly. Now, this is a very bad purpose, a very bad practice. Can you get my point? Very bad practice. Remember, anytime while you have the chemical inside the container, you have to, first of all, dilute it. How will you dilute it? Is by pouring into the beaker of water first, before you dump it into the sink. Okay? Of course, if you talk about the waste carrying heavy metal or is organic, you cannot directly put it in the basin. You have to pour it into the waste bottle found inside the film hood. Can you get my point? So this is the proper way of doing so. Why can't we do it in reverse? The corn acid, while you dilute it, it will have a lot of heat given out. So water, if I put water into acid, water it seems like sprinkling the water droplet into the cooking oil, hot cooking oil. So the oil that mixed with the water will spread out. It will sputter onto your face. It will splash out so easily. Do you know why? Because the water itself will boil at that point. 即係點解咁樣有問題咧？有冇人知啊？ So the corn acid is here. So what will happen is that if I have got water, okay, where? Tell me where? Yeah, here. If I have got a droplet of water here, okay, so there is a direct mixing, but once I mix it, it will give out heat. So what will happen? The water will directly heat or superheated to form a steam. Okay, while you change in the physical state, it will directly, this will not give you a change of state, but also KE, kinetic energy. They will push the water together with corn acid, and they will come out, and they will hurt you. Okay, remember, do not do this. But otherwise, but how about this? Why is it no problem? Heat will be dissipated. They will transfer to the water, because water is quite in large amount. You know, water is a very good cooling agent. It has a very high specific capacity. Do you know what is that? You know it in physics? Physics. Heat. 搞未？
未啊，教緊 work 緊啊。
哦，得啦，冇嘢，算啦。係俾熱用啊，即係佢吸熱咧，佢有好多水幫手同你吸熱啊嘛，所以咪佢係熱咗啊，不過佢未熱到滾，令到啲水滾咯。但係調翻轉下邊個機手啊，啲水會滾，一滾就大件事啦，就連埋啲酸一齊彈出嚟。And it also cause burns to your to the clothes, but also the skin. Be aware, right, while you handle the corn acid, because both corn acid and alkaline, they are said to be corrosive. Okay, so here comes the end of today's section. Now we have got about 8 minutes left. Okay, shall we have a recap of today's lecture? Right, we have a recap on what? We have a recap of qualitative analysis. You talk about drying agents. You talk about the corrosive nature of concentrated acid and alkaline. That are the three. So it's time to check your understanding by seeing the questions there. A quick check of your MCs. Quick check of your understanding. Okay, each of you will have got a chance to speed up. I start from 曾海軒。
睇到
Question 2, please. Which of all statements concerning acid is correct?
係 B 啊
B, yeah. The stomach, it contains the hydrochloric acid. We call it gastric juice. So inside we've got HCl. Okay. Number 3, 岑子謙. Look for the word ionic equations.岑子謙. Where are you?
I'm here.
I can't see you, right? Tell me, what is it?
A.
It's A. How you do the ionic equation? First of all, split the one with AQ into the separate ions. 2. What's the next step? Cross out the spectator ion. Okay? And you can get what you want. The answer is, you try again, tell me. It's B, not A, but not A. Number 4. 朱家賢
D is
is
D.
by exit, not a typical property. Base will react with exit to form salt and water. We call that neutralization.
Oh.
So it's correct. D is correct, but we cannot choose. You are choose for the answer which shows exit is not a typical property. Very tricky. This question, please take a look on the word by word very, very carefully.
It's B. B.
B,
B.
not boy, is it? Not reacts with carbonate to produce carbon dioxide. All carbonate can react with exit to form carbon dioxide. That's why addition of dilute exit is a chemical test to test for the carbonate. So this one is correct, but you still cannot choose. I'm doing it.
係
What is that? What can it be?
係咪第4題而家就係講緊？
係啊，第4條啊。B 嘅係啱嘅，唔揀得 ；D 係啱嘅，唔揀得。而家爭 A 同 C。
C。
唉，恭喜晒大家啦嚇！Dilute exit 係導電嘅，點解啊？因為有冇班人啊 ？A 唔啱 ，A 點解唔啱啊？
哦，
佢自己好穩定。
見唔到呢個字 ？All metal dilute exit cannot react with all metal to form hydrogen. An example:
gold,
silver, copper. They would not react with dilute exit. So A is not. You are write down the most metal, but not all metal. Very tricky, isn't it? Right? Number 5.馬志軒。
係咯。
What's the answer for question 5? You're going to add dilute NaOH into the solution in excess. Which of the following combination is correct? Boy. Yeah, boy. The white PPT is in the form calcium hydroxide. Question 6. Lay up. Choose the wrong statement.
係咪 C 啊？
Sulfuric acid. The formula for sulfuric acid is H2SO. 2. Di. correct, not chosen, should not be chosen。做咩？你哋玩閃避球嚟今日？鄭希哲，撞鬼嘅你班友，搭幾坐嘅？
第6條。D 係咪？
點啊？你哋呢度啊
多
？D slippery field is not slippery. Okay, alkaline is slippery, acid is not. 7. 關佩林。你今日我冇問你問題嗰啲啊，全部預備定啊，我會問你噶啦。Question 7. 關佩林。溶起水嘅4隻都溶起水啦。Addition of dilute sodium hydroxide to give a solution of X gives a precipitate. The precipitate dissolves upon the addition of excess NaOH. It may be NaOH。咁如果你講呢啲嘅話咧，你其實一開始咧乜都唔使睇噶啦，即係 anion 嗰邊唔使理噶啦，就係睇 cation 啫，係咪？咁邊個借答案？Hello。
C
係啦 ，C 點解咧？因為 form 咗第一 form PPT 咧，係咪 form 咗 lacto hydroxide 加 excess 嘅 hydroxide 咧，就會變做 pumbate， 就係冇色嘅 complex。OK， 第8。第8，余康俊。係咪頭先嗰條題目講嘅嘢？邊個 set up 係好 OK 啊 ？Dry CO2 啊 ，CO2 係酸性氣體定係鹼性氣體啊？酸性啊，睇清楚。邊個就係答案 ？C 啱 C 啦。PC is a possible answer。吸完濕之餘，千祈唔好同 dry agent 就直接有中和反應。第9，何志康。第10條劉軒智答。11係鍾朗謙。12 Hewitt。13譚志仁。好，第9。Dot magnesium chloride。留意住上面呢條題目啦 ，NaOH 啦 ，acidify 啦。今日兩個都方位 PPT。咁 sodium hydroxide 咧就講緊嗰個實驗咧，就係 deal with magnesium ion 嘅，圈低啦。第二個就係 acidify silver nitrate，silver nitrate test 係試 chloride ion 嘅，大家都位 PPT 啊。咁啊分開兩個咯，即係呢個就係即係 identification 咯 ，identifying 咯。10。第10答案。
諗緊。
係。繼續諗啊，一陣會問翻你啦。11。
應該係 C
啊
，C
啊statement B。
或者 B 或者sorry B 或者 D， 我仲計
B 或者 D 啊。
係。
好 ，NaOH 同 ammonia 係 correct， 佢哋兩個都 react with MgCl2，咁你又留意啊，全部鹼啊嘛，咁就同金屬嘅離子有反應，大家咧都會形成 magnesium hydroxide PPT， 得唔得？所以 statement 1咧係啱嘅。第2咩啊？係 dot 啊？我揀1咯喎，1係 correct 喎。
真係
呢啲啊？你講咩啊？
答翻同
第
先問
幾條啊？
第10題。
第10條啊？你講咩啊？
答
多啊，多唔啱啊。好，11講咗11先，11咁啊1 statement 係啱啦，2咧2係錯嘅，因為咧佢話 deep blue solution 嗰個咩嚟嘅咧？其實咧就係
咩吸排？
scupper
哦，係
2 iron 咧，佢只有呢一個鍵係嘅啫，就冇嗰個4個 hydroxide Cu 跟住括弧2減冇嘅 deep blue solution 啊嘛，即係呢個有呢個冇嘅，所以咧而唔啱 both 啊嘛。第3 any which react with 酸 but not 咁你嘅錯啦，呢個係呢個係鹼嚟噶嘛，但係呢個係酸嚟噶嘛，咁嘅有中和反應啦，係嘛？咁所以3都係錯噶，明唔明啊？咁答案係 A 啦，中和反應嚟㗎。咁我答案就係 CH3COOH 加 ammonia 變成 CH3COO full NH4 正加 H2O。咁呢隻嘢好特別嘅，叫 ammonium ethanoate。得唔得 ？ammonium ethanoate。好，對翻第10。第10咧，答案係咩咧？第10咧，答案係B boy 啊。點解咧 ？limestone 啊嘛 ，flame test golden yellow flame 錯硬㗎啦，係 brick red。give the color gas when heated strongly 係啱啊，因為 limestone 係 calcium carbonate 加熱變成生石灰同二氧化碳。OK， 咁個二氧化碳咪 colorless gas 咯，啱啊。而 dissolve in dilute subreactant to give a clear solution。答案咧係錯嘅。點解咧？點解 D 係錯咧？因為 calcium carbonate 加酸之後係硫酸喎，變成咩咧？變成 calcium sulfate。留意住係固體嚟嘅，加 CO2 加 H2O。所以咧嗰個實驗咧就一開始有譜啦，但係啲譜突然間開始唔係好出，最後就冇晒啦。即係 coating effect 啊！記唔記得啊？3咧係好 tricky 嘅，自己圈翻低啦。3係超 tricky 嘅，所以唔揀得。12邊個答啊？12係
好似係我
係 Hewitt 嚟啊
D
，D 啱啦 ，D consol 啊係 oxidizing 同埋 corrosive， 留意住呢兩個嘅 hexavalent label。13以下邊個可以用排水法
cat
？cat 啱啦 ，OK。HCl 唔得啊，因為佢係超溶喺水嘅。咁個問題又嚟啦 carbon dioxide 唔係溶喺水嘅咩？佢唔係 highly soluble，所以係冇事嘅，就冇嗰個 sucking back 個現象冇咁唔會出。但係 HCl 就唔係啦，係啦，得唔得？即係所以咧，如果你話 bubble oxygen 都得㗎 ，oxygen 都溶喺水㗎嘛，不過咧唔係 highly soluble， 掂唔掂 ？OK， 好，喂唔掂喎，下個禮拜禮拜3要加操啊，你哋做翻啲練習。咁咧下個禮拜有實習老師嚟嘅，咁我會一陣間喺嗰個 Google Classroom 話翻俾你聽 announcement。咁究竟我用我個曲啦，我用個同嗰個 student teacher 個曲啦，等等啦，上堂應該點啦？咁嗰啲嘢我會喺 Google Classroom 發布啦，得唔得 ？OK。咁啊，一陣間喺 WhatsApp 度話翻俾我聽啦，你0到10啦，因為你而家都晏啦，你要 break 啦。好，係咁，拜拜。
拜拜。